Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet. Today's host is Dan Kazwara, and he is their field application engineer and will be presenting today. If anyone has any questions, please submit them in the question box, and Dan will answer them at the end of today's presentation. Dan, thank you so much for being with us today. I am finished for now. Please go ahead and take it on over.
Okay, thank you, Julie. Thank you for having me today. Okay, so yeah, I'm Dan Kazwara. I'm with IgniteNet EdgeCore, and you're probably seeing that the webinar was for IgniteNet, but you see EdgeCore. So if you don't know, EdgeCore is actually part of IgniteNet. Actually, EdgeCore owns IgniteNet. It's still, they're one of the same. So the product lines that I'm going to cover today, next generation products, are under the EdgeCore brand name, but ultimately they're from the same ultimate company. Okay, so there we go. Today's agenda. Okay, so what I'm going to talk about, the new generation of products, is the Terragraph products. The distribution node, the client node, these are the next generation 60 gigahertz radios. As you know, IgniteNet's well known for the 802.11ad 60 gigahertz radios. So the next generation product will be under the EdgeCore name brand, but is the 802.11ay next generation product. And also Wi-Fi 6 indoor 802.11ax APs. I'll be covering that as well. Okay, so there's just kind of a timeline. In 2015, IgniteNet was started with the 802.11ad 60 gigahertz solution. Started with point-to-point, went to point-to-multi-point. Probably a lot of you guys are familiar with the existing products. In other words, the MetroLink product line. So I'll use some comparison today to give you an idea of how they're similar and how they're different, the next generation of product. And then now today we have the Terragraph products here in 2020 and 2021. Okay, so the main distribution node here, the MLTG360, is kind of similar to the Omni that you may be familiar with. It's the name, of course, 360 degrees. Now, 60 gigahertz, in order to get the dB gain up, you don't just have one radio. You'll see our Omni had three 60 gigahertz radios in it. You'd have to have separate channels, and you'd have X amount of clients, connected to each sector, and they're 120 degree sectors, and three of them give you 360 degrees. This one is 4 radios, so it's 4 90 degree radios to get you 360 degrees. It actually supports more clients than our older Omni does. 15 clients per sector. There's 4 sectors, so that would be a total maximum of 60 clients off one of these. The gain is slightly higher as well. The dB gain on the Omni was around 17 or 18 dBi. This is around 22, 23 dBi. Also, the output power, it's not mentioned here, but the output power is higher. It's about 20 dBm compared to 14 dBm. So there's more output power and more dB gain in the direction it beamforms. It's a narrower beam. You could have 2 DNs go up to 300 meters, and you could do multiple hops. The latency is lower, so it could support more hops. Realistically, the limitation is really just an amount of latency you could withstand. There's not really a hard limit of 15 hops. Similar to the Omni, it has the 10 gig SFP plus port interface. It's IP66 rated. One thing, originally the Terragraph product, if for those who have dabbled with it a bit, if you know in the very beginning release, it only supported layer 3 or IPv6 Terragraph mode, if you will. Our now firmware does support also traditional layer 2 transparent bridging. And I know we had a lot of people asking about that and requesting that. And also, there will be soon support on our existing cloud, the IgniteNet cloud, now called the EC cloud. This product, like our other products, will be supported on the cloud soon. Okay, here's just showing the connections. on this. It comes with a standard like bracket that you can mount on a pole. You would mount it on the top of a pole. There is also an optional J bracket if you can't mount it to the top. Here is shown is it comes with that. If you were to mount it on the top, you could mount it with what you get in the box. There is, like the Omni, we have a DC in to power the device, or you could power it via typical way is the PoE in. It does have multiple ports out or in, if you will. They could be data uplink ports. Typically, the SFP Plus is used, but if you only have, say, 1 gig, you could use like LAN 1 or your PoE in as a data in port as well. Now, on a secondary, let's say you had a DN talking to a DN, the secondary DN could then act as like a point-to-point. The other side would then have an out. That would be like data out, if you will, and that could support local devices. We did initial testing, and we're seeing very high throughputs. DN to DN, well over 2 gigs, and close to even 4 in aggregate total at shorter distances, like 200 or 150 meters. We're at MCS 12. We're seeing like 4 gigs of aggregate throughput to each direction. It's pretty high. That's in our initial testing on point to point between those radios. Typically, they're not used point to point. They're going to be more oftenly used as an access point or a base station. Okay, so here's a diagram showing the radio. So figure 90 degrees, you got 4 radios. You got to know which radio you're connecting to. This is just showing how it kind of the overview of how it is. This is pretty straightforward. I mentioned this before. You know, the connections. You can power, for 1 gig, or you could do SFP Plus for the uplink. Okay, so now the options, I mentioned 360-degree coverage. That's the 4 radio. There's actually 5 radio options you can get. There's the 4 radio one that covers 360 degrees. There's a 270, which has 3 radios in it. There's 2 versions of the 180. There's 2 versions, meaning one will be north-south, while the other could be like north and then east, say 90-degree opposed to each other. So there's, depending on your deployment, you see in the diagram there, depending on your use case, you may need one or the other. And then there's a single 90-degree coverage, could be like at the end of something like in the diagram, or could be used as in a sense, a lower cost option for, like, say, serving as kind of like a client, like a high-powered, high-speed client connection. You could. It's another idea to use it in that way too, like a single radio. Okay, there's the optional J bracket. So the J bracket's if you can't mount it on the very top of a pole. So that's an option. Okay, now the client node. Okay, so obviously you got the base station, the DN, that's really primarily used as a base station. So the client node is going to be the client, and you can connect up to 15 of these per sector on the DN. So as I mentioned, up to 60. And again, beforehand, when these originally came out, they did not support transparent bridge mode. They do now. Firmware does support it, and like the DN, we'll be having this on the EC Cloud soon. Now, I didn't mention this before, but I want to mention the big change with the technology in performance that makes a difference. They're still using 60 gigahertz. It's TDMA versus carrier sense multiple access. So it's a more efficient protocol to communicate. So that's where we're getting the faster speeds. There is future support for, and we're waiting for it from the chipset manufacturer Qualcomm in hopes to do channel bonding that will actually increase throughputs even higher. Not really at the client side, because this will be ultimately bottlenecked by the Ethernet port itself. It's a 1 gig ETH port. You see the up to 1.8 gigs. That's kind of what you'd get from Ethernet. So, but more on the overall capacity on the DN side is where that channel bonding, and also TDMA allows you to use the same channel. So unlike say our Omni, where we have channels 1, 2, and 3, because they can't be on the same channel, this supports having the DN can have all four radios on the same channel, because the TX and RX timing are going to be in sync because of TDMA. So it's a huge improvement there. Now I say up to 150 meters. We recommend up to about 100 meters from client to DN for this one. The DN to DN, it's up to 300 meters, but we recommend up to about 250 meters. Now, I want to point out, unlike the Metrolink products, these do not have 5 gigahertz failover. So we have more output power, more dB gain. So the link budget is greater, but you can't, the distances are going to be similar or even slightly less, because you don't have that option to fail over to 5. You want to have 99.9 or better, uptime. You want to have that reliability. So we have a greater link budget, but we don't have the 5 gigahertz failover. So that's a little bit something to take into consideration, or I should say a lot. Okay, this stuff's pretty straightforward. Let me skip through this. Okay, pretty typical stuff. It's passive. People ask, how is it passive? Is it 802.3 AT or AF? No, it's passive PoE for the DN or the CN. It's passive PoE. It's a diagram showing what you could do. Okay, now this is the big one. If you notice, the range on the CN was only 150 meters, or actually we recommend up to 100 meters really for real, reliable link. We didn't have a true, say, replacement for our Metrolink 35 centimeter radio that can go about 500 meters, but now we do. So this is huge, because this is now really going to have the range of our, for example, our ML1 6035. It's 35 centimeter. This radio will have 3-degree beam. It'll be easier to align actually, but then it beam forms down to about 1 degree. It'll have, I think, around the same dB gain, around 42 dB gain. The range, it says up to 700 meters. That's DN to CN, LR, long range CN. Now, don't forget, when we say up to, I'd still recommend about 500 meters, because we don't have the 5 gigahertz failover. So I'd still keep that between 400 and 500 meters like we do our Metrolinks. You could also use point-to-point, so up to 1.5 kilometers. They do have more output power than our existing Metrolinks, so the link budget will be bigger. You could use these in transport layer 2 bridge mode, or you can use it in telegraph mode, which supports meshing and all those other things. It depends on what you're up to. Traditional WISP, we found, just typically want to use it in transparent, bridge mode. There are use cases where you want to use the mesh mode and using the OpenR protocol and taking advantage of those features that you can do to distribute. You wouldn't do it with the CN. I'm saying that's for DN to DN, but you do have the option. Okay, this is showing here. You can see the radio there mount. You can see it kind of has similarities to our 35 centimeter radio from before. The advantage, of course, now we have, thinking ahead now, the little bit of protection on the top there to prevent snow buildup and causing the signal to degrade. There's the bracket, and if you notice, that's the same bracket. So the brackets that you could use on the Metrolink product lines are going to work on this radio as well. The regular CN, which I mentioned, this radio back here, just has 2 small hose clamps, like 3-inch hose clamps on the back. That's all it takes. It has 90 degree beam width, azimuth, or horizontal. Vertically is about 50 degrees, so you don't really have to worry about too much negative or up tilt, down tilt. So just standard hose clamps would be fine. And here's showing the long range bracket. that is optional with the which typically people use on the, for example, like the existing would be the ML1 6035s, ML 2.5 6035s. That's typically where you use this long range bracket. We'd recommend you use it for this as well. You notice it still has the boss on the top to mount the gun scope that you can use to make it easy to align as well. Okay, next I'm going to cover the two new Wi-Fi 6 access points. So they're indoor APs. This one is they're AX 802.11ax 2x2. Interesting. I'd say that it has a 2.5 gig E port, so that's cool, and also has 2 additional LAN ports. High output power, 26 dBm, 400 milliwatts output power, 0.4 and 5 gigahertz, so very high output power. And people were asking about this. It does support mesh, so you can do that. Not just like regular bridging, but you can mesh. There's a using, I think it's the Batman kind of protocol for meshing. It's kind of using that. Now, number of users, I want to cover that a little bit. Now, AX, I don't know if you know the technology of the AX. One of the things was that it really increases overall capacity and number of users. This, where it says 50 to 60 users, you're going to see other competitors claim different numbers and ridiculous numbers. You know, I've been in Wi-Fi for a long time, CWNE, and one of the things we always talk about is, you know, manufacturers' claims can get out of control, right? 802.11, the protocol itself can handle so many clients on a channel, so much traffic. So you'll see these numbers vary wildly, okay? But realistically, would you want to have 250 clients on a single channel, on a single, let's say a 2.4 gigahertz channel or a gigahertz channel? No, that wouldn't be best practice. It would never work well. I don't care who makes it. So that's like a realistic number of what we suggest. Okay, so don't think that's we're any worse than any other manufacturer. We're on par with what the protocol can support. And our 4x4 radio. Okay, so this is and if you know the difference, the main difference is, of course, number of radio chains. It's going to receive a little better, so it has a slightly improved coverage because it hears better. It's got more radio chains to hear clients better. Overall throughput's better. So any client that's connected 3x3 or 4x4 is going to see faster throughputs. So this is like the high performance version. Where we recommend this, typically what we recommend is in very high dense user environments. You'd want to go with the 4x4, and let's say a normal light to medium network use, you could save costs and go with the 2x2. That's kind of typically how it's deployed and used. So those are our two new APs, Wi-Fi 6 APs. And yes, they are and can be supported on the cloud, the EC cloud. And the IgniteNet cloud, a lot of people don't know, but as of last year, the cloud has been upgraded to where even the free version supports 50 clients or 50 devices for free. Then it's just $9 a year. But it used to be just 2 clients or 2 devices. Now it supports 50. So I just wanted to mention that as well. Okay, that was a quick webinar. I just want to go over some new products we have, and that's it. Do we have any questions?
Hi, Dan. Thank you so much for that presentation. Yes, we do have some questions here. Let's go ahead and get started with the first one. Okay, right here we have, what PoE power voltage does the MLTG 3600 support?
Okay, that would be just traditional, like 54. I'm sorry, 48 up to, I think 57 is the highest you can go. Higher than that, you shouldn't go. So like 48 to 57 volts.
Excellent. Thank you, Dan. Let's go ahead and go to the next question. What is the maximum distance of deployment of the MLTG 360?
Okay, so 360 to 360, them two to each other would be 300 meters max. We don't recommend the maximum. We say around 250 meters. So that's recommended, 250 meters. Now, a CN, the regular CN, we recommend 100 meters, even though it's 150 max, we recommend 100. And if you use our long range client to the DN, then that's 500 meters recommended, 700 meters max. And the last thing is CN to CN, both long range models can go 1.5 kilometers.
Great. Thank you so much for that, Dan. Next question here for you. Would a warranty be voided if a customer uses a different wall bracket?
I don't think so. I guess if it compromised the housing to where it resulted in some sort of failure, like let's say you used a bracket that caused the something to, you know, compromise its integrity, which caused water damage, which caused the radio to not work, sure. But if it's unrelated issue, like an electronics failure that's unrelated to anything you do, a bracket you use shouldn't matter. Yeah, it should be fine. Yeah.
Great. Thank you for that, Dan. Couple more questions here for you. What is the purpose of the USB 2.0 for the EAP 102?
Oh, that could be used for a BLE Bluetooth dongle.
Okay. Got another question here for you. Are the indoor APs rated to use outdoors, say in a covered outdoor area?
Yeah, so a covered outdoor area, no, they're not IP. I think you're looking at like IP55 or something. They're not IP rated for outdoor use. So these are indoor APs.
Gotcha. Thank you. Next question here for you. For the MLTG-CN and any other edge core devices, are users able to upgrade their firmwares? In other words, do they also have auto firmware update feature?
On which model again? I missed it.
VMLTG-CN and any other edge core devices?
Okay, currently not automatic. You have to go into the UI and do the firmware upgrade. In the future, when it's supported on the cloud, then of course you could have the option to automatically or manually tell it to upgrade from the cloud to upgrade to the firmware on the device. Currently, you just log in locally and do it. And oh, I didn't mention this, is people are probably going to ask this, adding in the answer, a question to an answer, or answer to a question, is when will the devices be supported in the cloud? We're shooting for around December, January. And when will the long range version of the CN be available? We're shooting for around January.
Thank you so much for that, Dan. Yes, that was excellent. Okay, couple more questions from this end still. Are there any monthly or annual subscription charges for cloud access?
No, that's what's really good. You can get 50 devices for free. You just create an account, you create your username and password, you log on into cloud.ignitenet.com and you create an account. And yeah, you could add up to 50 devices. These could be indoor access points. These could be their 60 gigahertz radios, point to point or point to multi. It does both. So it used to be just 2, and then after 2, you'd pay $99 a year. Now it's 50 devices, and then it's, if you go past 50, figure you got pretty good amount of stuff out there, and then it's still just $99 a year, which isn't still not very much.
Excellent. Thank you, Dan. Couple more questions here for you. Can a user also download their configurations and be able to restore them from the user interface when needed?
Yes, yeah, there's an option to restore backup configuration file. We recommend that when you do, you match it to the firmware of which it was running when you backed it up. A lot of people have a problem with they run a firmware and then 5 generations later, a firmware, they upload a backup config file and they cause problems. That's the only caveat I recommend for people. But yeah, all our radios have a backup config file download option, then upload option later.
Thank you, Dan, for that. Next question. What are all of the frequencies you manufacture devices with?
Okay, so currently it's it would be traditional Wi-Fi 2.4 and 5 gigahertz, and then the other frequency would be 60 gigahertz. So the Metrolink product line and now the Telegraph product line both are 60 gigahertz radios. And to add to that, I believe this might be a question, so I just thought of it, is there any backward compatibility with our 60 gigahertz radios? Meaning, does the Telegraph, could it work with our Metrolink? And the answer is no. There's no way it could support it. And the main reason is because of TDMA. I mean, the Telegraph radios are all TDMA. All the Metrolink radios are carrier sense multiple access collision avoidance, you know, the older 802.11, you know, typical protocol. It's still very fast. I mean, but performance wise, we're probably seeing on an order of like 50% or better performance on the next generation with the Telegraph stuff. So we're excited about that. So hopefully that kind of answered the question there.
Yes, thank you so much. Dan, can you tell us where is the best place to go to, perhaps your website, if one wanted to get either customer support or technical support? Can you point us in the right direction?
Yeah, I mean, you could just go to support. You can email support at ignitenet.com or support at edge-core.com. So either way, edge-core.com has more information on these products. So I would go there as far as like the Telegraph products and the Wi-Fi 6 products. That's where you're going to see them.
And for warranties, would we find some warranty information there as well?
Yes. Yeah, it's the same warranty that you would have with our IgniteNet products, which was a 2-year manufacturer's warranty. So yeah, you'll find information there.
Excellent. Thank you so much. Dan, can you give us an overview about where your products are manufactured?
Well, it's in Taiwan. That's the main manufacturer's point. It's pretty straightforward. That's where they're made.
Great. Okay, Dan, thank you so very much for answering those questions for us this morning. And also thank you to everyone for attending today. And if anyone has any further questions, of course, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of these products mentioned or shown today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and will be uploaded to our Microcom YouTube channel so you can view it again. Dan, thank you so much for taking the time and covering all of this product and information with us today. It's very valuable. We appreciate it very much. Everybody have a fantastic rest of your day.